Yes, now we are coming on next question on relation. Question says R and S. This is a new type of question. R and S are two equivalence relations on set A. On set A, there are two relations R and S. Then we have to prove that R intersection S means those two relations which we are having, that is the collection of order pairs we have. If we take their intersection is also an equivalence relation. We have to prove this. So how to start this question? Just check here. First we say, first we check whether this is a relation or not. If it is a relation, then we think about the equivalence condition, or we'll say equivalence relation we'll find out. So first we say as R and S are two relations on set A. Therefore, what I should say, R will be a subset of A cross A. We have already done that. If R is a relation, always a subset of A cross A. And at the same time, S is a subset of A cross A. And if R is a subset of A cross A and S is a subset of A cross A, what does implies? This implies R intersection S is also a subset of A cross A. And now if R intersection S is a subset of A cross A, what does it imply? This implies R intersection S is a relation. Whenever it is a subset of A cross A, it is a relation. If it is a relation, then it will be a subset of A. So R intersection S is a relation on A. So first thing we have checked whether it is a relation or not, we have verified it. Now coming on that it is a equivalence relation or not, for that we start with the reflexive relation now. In reflexive relation, we will start with let A is any element. Let A belongs to A. This implies A will be a member of R because A is a reflexive relation. Equivalence given, equivalence means reflexive, symmetric, transitive. S is also equivalence, so reflexive, symmetric, transitive. So first this, and at the same time A belongs to S. And what you will write as R and S are reflexive on as they are reflexive on A, so we will say this condition will hold, this condition will hold for all A belongs to A. And if this is a member of R, this is a member of S also. What does it mean? This implies A is a member of R intersection S. For all A belongs to A. So what I got here, A is a member of R intersection S for all A belongs to A. And whenever this condition holds, we should say R intersection S is what it is reflexive relation. Is reflexive relation on A. So first thing we have proved that it is an reflexive relation. First we have proved that it is a relation, then we have proved that it is a reflexive relation. Now coming on next condition, symmetric relation. Symmetric relation. In symmetric we will take let A and B belongs to A such that AB is a member of R intersection S. First I'm taking AB is a member of R intersection S, and if I prove that the BA is also member of R intersection S, my question will be over. So we start with this. AB is a member of R and at the same time AB is a member of S. If AB belongs to R intersection S means it will be in R also, it will be in S also. And if this condition hold, we have done AB is R, then BA will be also belongs to R, and at the same time BA belongs to S also. Why it is? Because R and S are symmetric on A. So if it is symmetric, R is symmetric, then AB belongs to R, then BA also belongs to R. AB belongs to S, then BA also belongs to S. So in this case, what I should say now, BA is member of R and S, so BA belongs to R intersection S. And if you get BA belongs to R intersection S, for all A and B belongs to A, therefore what I should say, R intersection S is symmetric on. Not a very difficult question, but only the thing is we should know how to write this question. Then comes transitive. In transitive, we will take three members. Let A, B, and C belongs to A, such that, what is the condition we have? AB belongs to R intersection S, and at the same time, BC belongs to R intersection S. And what I have to bring? AC is a member of R intersection S. So what do here? AB belongs to R intersection S means AB is a member of R, and at the same time AB belongs to S. This is the first condition. Then end is here. Then it comes BC is a member of R, and at the same time BC is member of S. If you get this, then check AB is a member of R, BC is a member of R. So we'll write them together. AB belongs to R and BC belongs to R. And at the same time, AB belongs to S and BC belongs to S. And if AB belongs to R and BC belongs to R, we have already done that AC belongs to R. And at the same time, AC belongs to S also. And here we will write because R and S are transitive relations on. So AC belongs to R, AC belongs to R, S, because R and S are transitive relation on A. And what does it mean? This implies AC belongs to R intersection S. And therefore, what I should say, R intersection S is transitive on A. And if it is reflexive, it is transitive, it is symmetric, we will say yes, this relation R intersection S is also equivalence relation. So it's a good question, NCERT problem. Please do it once more yourself and we'll be able to do this. Now we are coming on next question. Next question says the union of till now I told you R and S are two equivalence relation, then intersection is equivalence. Now they are saying that R and S are equivalence relation. Their union is not necessarily a equivalence relation. Necessarily not there, it means there is a contradiction which you have to show and you have to prove that it is either transitive, reflexive, symmetric, one of the condition fails. Then we will say it is not valid. So for that we'll start with this way. Let A set we are having three elements A, B, C, and R is a relation which have A, which have B, which have C. If it is there means it is symmetric, reflexive. Then if it is AB and BA, it is transitive also and symmetric also. These three member must be for this reflexive condition. Yes, they are there. AB and BA in pair, that means it will be symmetric also. Then A relates with B, B relates with A, then A and A relate, that means transitive is also And S will take another relation. It will have A again, B again, C again, then it will be BC and CB. It is another equivalence relation because again 3 gives reflexive, symmetric, and BC CB means BB again there, so that means we'll say transitive. So we will say clearly R and S are two equivalence relations on A, and we go for R union S. When you go for R union S, what change will be there? A will come, B will come, C will come. Then comes out to be what? AB is here, BA is here, AC is here, sorry, BC is here, and CB is here. So this relation, if you think, is it reflexive? Yes, because all three members are there. It will be symmetric also. Yes. Why it is symmetric? Because AB, BA is there and BC, CB is there. But what you will find here in this case, AB is a member of R union S. And at the same time, BC is a member of R union S. But this is given, but, or you write down here S. AB is a member of R union S, BC is a member of R union S, but AC is not a member of R union S. AC is missing here. So we will say R in union S is not transitive. And if it is not transitive, what I should say? Relation is not equivalence. Relation is not equivalence. So keep in mind, union when I take, then reflexive condition is going to be fulfilled, symmetric is going to be fulfilled, but transitive in this case does not fulfill. So I've given an example in which you will find that the union is giving reflexive condition, symmetric, but transitive fails here. So that's why the equivalence relation cannot be possible here. So this way you will be having another example from NCERT. One more example I'll take. Yes, this is the question we have. Given a non-empty set. Non-empty set means it has certain element, and Px is its power set. R is the relation defined on power set. Means relation is going on power set to power set. Means it will have the subsets. It will also have the subsets of X. And how it is defined? Relation is A and B are the two subsets. They are related if A is a subset of B, where A and B are members of power set, is an equivalence relation. So we have to show that the relation is equivalence if this condition is given as a relation. So start with this. Let A is an element of power set of X. If A is an element of power set of X, this implies, or we know now, then we know. What we know? A is a subset of A. A is a subset of A. Then we know A is a subset of A. And if A is a subset of A, it means what I should say? A belongs to R. Because it says A relates, A is a subset of A, then relation is there. So A belongs to R. For all A belongs to power set of X. Therefore, R is reflexive on A. Now coming on second case, it's clear. A, we have taken one member of power set, and every set is a subset of itself, so hence we will say they are related. Second condition, we will take now symmetric. Let A and B belongs to power set of X such that A and B belongs to R. If A and B belongs to R, it means A is a subset of B. A is a subset of B. But B is a subset of A is not necessary. B is a subset of A is not necessary. That means we will say B A belongs to R is not necessary. And if it is not necessary, therefore what I should say, R is not symmetric. And if it is not symmetric means we will say the relation is not equivalence. Is not a equivalence relation. So we will say in this case R is not symmetric. So therefore we will say R is not. So it is the question, we are correcting it again. This question says is equivalence relation or not. So we will say R is not equivalence relation. So it is justified that in every case it is not equivalence relation. If A is a subset of B, we get it. So this way we have completed chapter relation. Few questions we will discuss later. That will be in our June class. Other questions I have done here, and next class we will be starting with the functions. So you should complete relation part now.